Hi everyone. One of my students was asking about, do they have to use completing the square? Well, a lot of the times you don't have to, you can use other methods. But for the moment, he's just showing you how it works. Let's have a look at it. If it just said complete the square, I want to turn that into a situation where I get two brackets, and this bracket is the same as that bracket. It so happens if I halve the 6 and I multiply it by itself, I get a 9. So if I halve the 6, which is 3, and I multiply it by itself, 3 3s are 9. So a lot of people look at it and they go 6 on 2 and square it. And you can complete the square. Let's have a look at what happens. Then you need two numbers that multiply to multiply to 9 that add up to 6. Could be 1 and 9, and of course 3 and 3 is the only possibility. How can I get an x squared when I'm multiplying that x times that x? If I expanded the brackets, would get me the x squared. That plus 3 and that plus 3, if I expanded the brackets, would get me that plus 9. How do I get the 6x? There's a 3x and there's the other 3x. So this is the reason why we halve that 6, because we want half of it on this side and half of it on this side. So when we add those two together, we have that pair is 3x and that pair is 3x, we get 6x. And that's why it works. And it's called completing the square, because that's the same multiplied by itself. I can now write that as a square. Do the same question, but over here, we're solving an equation. Now we could use a quadratic formula to solve this, but let's use it as completing the square. So if I wrote that as two brackets like that, and I had the 2 over there, what's the method? It says to halve the 6 and square it. So if I halve the 6 and square it, I've got a plus 9. Now if I added 9 to this side here, to keep the equation balanced, I've got to add 9 to the equation over here. So let's go back over what we did. To complete the square, this one here, we were just completing the square. It wasn't an equation, just saying complete the square. Learn that first, basically, so you can do questions like this and more. Let's have a look at it. So you halve the 6, which is 3, multiply the 3 by itself, you get a 9. To balance an equation, if I add 9 to one side, I've got to add 9 to the other side. So this will become an x plus 3 and an x plus 3. And this would, instead of a 2, would then become an 11. So if I wrote this now as x plus 3 all squared equals 11, then I can solve this equation. The opposite of a square is square root. Remember, they're called square and square root because they are the opposites of each other. Square and square root, same for cube and cube root. So if I want to get rid of the square, I can take the square root of this side and the opposites cancel each other out. So if I get the square root of this side, I end up with x plus 3, and I get the square root of 11 over here. The problem is, when you get rid of a squared, you've actually got two possible answers, and that's here. If I had x squared equals, say, I don't know, let's say 25, what times itself would give us 25, and there's two answers. Of course, 5 5s are 25, and the other one is minus 5. So there's going to be two answers all the time. So if I had x squared equals as simple as 1, there's two possible answers, and the two answers are x equals there's a plus 1 or a minus 1 answer. And that's where we come up with this plus or minus. Instead of writing the 2, mathematicians like to write them together as a 1, and it's like this almost a new expression, plus or minus, but it's actually plus or minus. Go back to over here, when I get rid of a squared, I end up having a plus or a minus. And also that a square root by definition is positive. So there's my two possible answers, but then I've got this 3 to get out the way. If I get rid of 3 from this side, I get rid of 3 from that side, and here's my two answers to the question. My first answer is plus root 11 subtract 3, and my second answer is minus root 11 subtract 3. Now we'll go through the same process here, just different numbers. See if I've got enough room to fit it in. Let's have a look at this. Okay, what do I do to this? I want two brackets. I don't need to write the 3 at this stage. If I halve the 4, it's actually halving a minus 4. But when I halve the minus 4, I get a minus 2. And when I go minus 2 times itself, is positive 4. So I'm going to add 4 to this side, I add 4 to this side. If you want to, you can put it on the next line. I'm just a bit limited for space, and spread it all out. So now we've got x squared take 4x plus 4. We want two numbers that multiply to 4 that add up to 4. We need x's because x times x will be x squared. Now this time it's a minus 2 times a minus 2, which means that when we multiply the minus 2 by the minus 2, we end up with the positive 4 up here, and that will equal 7. So in brief, half the 4, half the minus 4 if you want to think that way, is minus 2. Minus 2 by itself is positive 4, so there's our add 4. It's an equation, so if I want to balance it up each side like a seesaw or a set of scales, if I add 4 to this side, I add 4 to that side. So we've got x minus 2 squared equals 7. How do I get rid of a square? If I wanted to, I could put big square roots here and do stuff, but it just gets too cluttered. So I'm going to leave it as x minus 2 equals root 7. And then you've got to remember that when you get rid of a squared, we have two answers. We have a positive answer and a negative answer. So what are my two final answers? Plus root 7. How do I get rid of a minus 2? If I add 2 to this side, I add 2 to that side. So one of my answers is root 7 plus 2, and the other answer is minus root 7 plus 2. The incredible thing is, if we substitute that back into this equation, it's one of the only two numbers that makes it true. I could do it as a decimal, you could be fussy and you can get very accurate, give that to lots of decimal places. Those two answers are the answers to that. There's one other situation to use it, but not for this video. It'll come in future ones. Thanks.